All right, we are live. Okay, so section 4.4, we're going to talk about the laws of logarithms. Okay? This is a section that students love to get wrong, apparently. Okay? So I'm going to have three rules here, but before I give you this rule, let me just ask you really quickly. If you had x squared times x to the third, what do you do with the exponents in that case? You would add them, right? X squared, or x 2 plus 3 equals x to the fifth power. Does that make sense? Now remember, logarithms are ways to deal with exponents. So, for example, you know, I'm going to change this slightly because I think it'll be a little easier. Log base a of xy equals log base a of x plus log base a of y. Okay, these don't have to be the same, but the idea here is just as we added exponents here, you can add logs together. Okay. Then rule number 2: if I had x squared over x cubed, what do I do with the exponents in that case? Venus? You would subtract them. That would be the same thing as x to the 2 minus 3, which would equal x to the minus 1. Okay? So, in this case, it's going to be the same way with logs. Log base a of x divided by y equals log base a of x minus log base a of y. Okay? And then finally, rule number 3, we've been using this rule a lot, but we're going to just state it again. Log base a of x to the c power. You can tell me what to do with that c, Javier, can't you?
Bring it down.
Bring it down in front, right?
Yeah.
So that's c log base a of x. Okay? So this chapter is going to be basically using all of these rules. Okay? So we're just going to do a lot of practice here. Let's say, for example, I wanted to evaluate, without a calculator, log base 4 of 2 plus log base 4 of 32. Okay. Now, Michael, when you see the plus, and the bases are the same, right? Bases are the same. Which rule applies to that? The first one. Okay. So I could write this as a single log in base 4 of 64. And 4 to what power equals 64? Well, 4 times 4 is 16, right? 16 times 4. And I got how many fingers up? 3 fingers. Okay? Because otherwise, log base 4 of 2 is kind of hard to figure out, and log base 4 of 32 is kind of hard to figure out, right? So if you can combine them together, you get a nice even number. Now, let me just mention here something. If you did this on your calculator, you'd probably get like 2.999999999. And then I will know that you weren't using the logs correctly, and I'll mark it wrong. Okay? So make sure you're using these rules because this can give you an exact answer. Okay? How about if I did the log base 2 of 80 minus the log base 2 of 5? Which rule will work with that one, Jeffrey?
The second one.
Second one, right? We can combine these. Right, this is a single log, which is log base 2 of 80 divided by 5, which equals log base 2 of 16. And you can figure that out without a calculator, right?
Yeah.
2 times 2 is times 2, times 2. And how many fingers do I have up?
4.
4. So that equals 4. Okay? All right. So how about minus 1/3 the log of 8? Tyler, must be your turn. Which rule could I use? Yeah. You can rule number 3. And so what do I do with this? Yeah, we're using these backwards, aren't we?
Yeah.
Okay. So I can put that over on the exponent of this. So this becomes log of 8 to the minus 1/3 power. Now, can you rearrange that, write that a different way? Especially without a negative exponent? Or a radical or something? So, yeah, so I could write this as the log of 1 over the cube root of 8. And you said that was 2, right? So this becomes log of 1 over 2. Now, we could actually use this again, right? So, because I could write this as the log of 1 minus the log of 2. What's the log of 1?
Log of 1. 0.
It's 0, so that's just going to fall away, right? That's 0. And the log of 2, you could plug that in your calculator, and you would get 0.301, but you're going to subtract it from 0, and it's a negative 0.301. Okay? All right. Now, what if I said I wanted you to expand oh, thank you. Expand log base 2 of 6x. Okay. Well, we're still a little bit low on the board. There we go. Expand log base 2 of 6x. So Nathan, what do you think? Which one of these rules do you think would be most useful for that problem? The first one, right? So let's apply rule number 1, and then this would become
Log 2 of 6 plus log something of x.
log something of x. I'm just going to keep the same base.
Okay.
Okay? That was easy. You're going to use my test? If it's that easy? I'll throw a lot of hard ones on there, and then you won't get that one right because it's too easy. All right, how about this one? What if I said expand log base 5 of x cubed y to the 6th? Demi, it must be your turn. What do you think?
Would it be the second rule?
Okay, we could use the rule number 2, and that would become
Log base 5 of x cubed over y to the 6th.
Is it over? You said over. Did you mean over?
Oh, is it the x cubed?
We're using rule number
2?
1. We're using rule number 1.
Oh, number 1? Oh, okay.
Sorry, I didn't remember right question.
Oh, so then it would just be plus.
So it would be plus, right?
Okay, yeah.
So plus,
Y to the 6th.
not y to the 6th, log base 5 of y to the 6th.
Oh, okay.
Okay? So yeah, you can kind of think of this as distributing blockable. That's not exactly what's happening, but kind of like it. Okay? Are there any other rules now that I can use on this one?
Use the third one.
We can use the third one, so we can pull both of these out, right?
Yeah.
Right? So this becomes
3 log base 5 plus 6
of x plus
6
6
log base
log base 5 of
y.
y. Okay? Now, if you get really good, you can go from there to there in one step. But if you want to do it in 2 steps, that's fine too. Okay? All right, how about the ln of AB over the cube root of C? This one looks like a good job for Andrew. I think we can use all 3 rules all at once if you wanted to, or you can take them one at a time.
Start with number 2.
Start with number 2, okay?
You keep ln or just change this?
Well, ln is just a different base of a log, so you can keep it down if you want. ln. Divided by 3, the cube root of C. Actually, I shouldn't put that there. And then what? Minus. Do you guys agree with them? Who agrees with them? Who disagrees with them? Okay. Joey, what do you think?
Sure, but would it be like ln of A isn't like ln of A plus ln?
Those are multiplied, right?
Yeah, would those two
So
be?
you want those to be added. Okay. Now we've got to divide. I wanted to subtract here. So rather, technically that's not wrong, but you might as well just subtract it at the end. So if I subtract what? The ln of C to the, well, you can leave it as the cube root of C if you want. Okay? Oh, I didn't realize we're out of time. Here, let me hurry through these really quickly. Usually you guys get done early. Okay, so let me finish this really quickly. ln of A plus the ln of B minus 1/3 the ln of C. Okay? The last thing I wanted to show you guys really quick is the change of base formula. Okay? And then we'll be done. Change of base. Okay, the idea here is with the change of base formula, you can change any logarithm from one base to another with this formula. Log base B of x equals log base A of x divided by log base A of B. Okay? Now, on your calculator, you've got common logarithms and natural logarithms. So typically, like if I wanted log base 3 of 7, let's say, I could change that to the ln of 7 divided by the ln of 3, or I could change it to the log of 7 divided by the log of 3. Those are the two most common. I could also change it to the log to any other base. Log base 4 of 7 over log base 4 of 3. I could do that too. But these are the two most common because that's what you have on your calculator. Nobody has that one on their calculator. Okay? And in all three cases, I should get this. I should have used the one they used because I don't know what that answer is. What did they use? They used an 8 and a 5. So if that's an 8 and that's a 5, and that's an 8 and that's a 5. In both cases, if you plug it in your calculator, you should get 0.7729. Okay? So the quiz tomorrow is on 4.4. See y'all tomorrow.
I have a question. Do we have a test